These are the notes for Algebra 2, and they involve solving quadratic equations by factoring. We've already been looking at the process of factoring and factoring completely, and now we're going to see how we can use the process of factoring to help us solve quadratic equations without having to draw a graph. Now, the key point behind the factoring method is what's called the zero product property. The zero product property says that if the product of two expressions is zero, that is, if I have two expressions and I multiply them together and I get 0, then one or both of the expressions must equal 0. And here we have it in more algebraic terms. If I have two expressions, a and b, if a times b equals 0, then a equals 0, or b equals 0, or they both equal 0. That's how multiplication works, because we know that 0 times anything is 0. Now let's see how we put that into practice by doing some examples. We're going to start with examples that don't require factoring, and then we'll move on to some examples that do. Now looking at number 1 here, example number 1, I have x times x minus 2 equals 0. Now what you need to notice here is that I have two expressions. One expression is just x, and one expression is x minus 2. So I have one expression times another expression, and it equals 0. Which means, according to the zero product property, that either x equals 0 or x minus 2 equals 0, or both. Now if x equals 0, that's pretty straightforward. X equals 0, that's one of our solutions. Remember, a solution to a quadratic equation is usually written as x equals a number, because that's where it crosses the x-axis. That's the x-intercept. Now, so one of the places where it crosses the x-intercept is at x equals 0. On the other side, I have x minus 2 equals 0. That means that x equals 2, because we could add 2 to both sides and we get x equals 2. So our other answer is x equals 2. So if we were to graph this quadratic equation like we did before, we would see a parabola, and we would see that the parabola crosses the x-axis where x equals 0 and where x equals 2. So this is kind of a way to get that same solution, that same root or zeros or x-intercepts, whatever you want to call them, without having to draw a graph. Here we have x minus 3 and x plus 4. So x minus 3 times x plus 4 equals 0. And again, if we were going to solve this using the graphing method, we would graph this equation and see where it crosses the x-axis. But what we're going to do instead is use the factoring method. Now this is the zero product property, says that x minus 3 equals 0, since this equals 0, or x plus 4 equals 0. And of course, if we added 3 to both sides, we would see that x equals 3 as one answer, so the parabola crosses the x-axis when x equals 3. Or we could subtract 4 here, and we would get x equals negative 4. So the parabola would also cross the x-axis at negative 4. And those are our two solutions. A little bit more complicated, but it's the same idea. I have 2n minus 4 times 3n plus 5, and this equals 0. So again, if I wanted to graph this quadratic equation and look at where the parabola crosses the x-axis, I would be able to see where that is. But I want to use this zero product property to find where it crosses the x-axis instead, or I guess in this case. So according to the zero product property, since 2n minus 4 times 3n plus 5 equals 0, either 2n minus 4 equals 0 or 3n plus 5 equals 0. And we need to solve both of these equations for n, and those will be our solutions. So over here we start by adding 4. This is a two-step equation. We've solved many of these before. 2n equals 4, so we divide by 2. We get n equals 2. Excuse me. N equals 2. On the other side, I could subtract 5. And I have 3n equals negative 5. Again, just a two-step equation. Nothing new, nothing we haven't seen before. We divide by 3. And tells me that n equals negative 5 over 3. And we could leave that as a fraction, or we could change it to a decimal. Since this would be a repeating decimal, I'm going to elect to leave this as a fraction. So negative 5 over 3. So these are the two spots where this equation crosses the x-axis. Now we're going to look at an example where we do have to factor first. Now remember, the zero product property says that if I have two expressions multiplied together and they equal 0, then one or both of the expressions must equal 0. But here, this is just one expression. It's one trinomial. And in order to use the zero product property, we have to factor this trinomial. So that's what we're going to do. We're going to factor this trinomial. And this factoring works exactly the same way factoring has since we started it. We take the first term, we put it in the top left, last term, bottom right. We multiply them together, and in this case, we would get negative 56. Let me rewrite that so it looks a little bit better. Negative 56x squared. And we would want the factors of negative 56x squared that add up to negative 1x. And we could go through our factors, and what we would find that the factors we needed would be negative 8x and positive 7x. Negative 8 times 7 is negative 56. Negative 8 plus 7 is negative 1x. So those are going to be the factors. We're going to put them in the last two squares. And of course, again, we look for the common, greatest common factor here. And we see that I have an x for a common factor in this column. If this is x, then this would have to be 2x, because x times 2x is 2x squared. Now I need to multiply 2x by negative 4 to make negative 8x. 2x times negative 4 is negative 8x. X times 7, positive 7, would give me 7x. So my factors are x minus 4 and 2x plus 7. We're going to use those factors because now what I want to do is rewrite this equation using my factors. So I'm going to replace this trinomial with the equivalent factors. So this would be 0 equals x minus 4 and 2x plus 7. And of course, now we can use the zero product property, because according to the zero product property, since the product of these two expressions equals 0, that means that either x minus 4 equals 0 or 2x plus 7 equals 0. And of course over here, add 4, we get x equals 4 as one of our solutions. So one of the places where this quadratic equation, this parabola, crosses the x-axis is at 4. Over here, two-step equation. So we're going to start by subtracting 7. We have 2x equals 2x equals negative 7. Divide by 2. So x equals either negative 7 over 2, or we could just say negative 3.5. It's not a repeating decimal, so I'll write it as a decimal. So this parabola would cross the x-axis at 4 and negative 3.5. Alright, we're going to do one last example together, and then you'll do the final 2 examples on your own. I have a squared equals 24 minus 5a. Now the thing is that I can't solve a quadratic equation unless it equals 0. We remember that from when we first started solving quadratic equations. They have to equal 0. So I need to move this a squared to the other side. Or I need to move all of this stuff, the 24 minus 5a, to the left side. It doesn't matter which one I do. The process is going to stay the same. So I'm going to move the a squared over. So I'll subtract a squared on both sides. And that would give me 0 equals 24 minus 5a minus a squared. Alright, since the a squared doesn't combine with anything, it just sits there at the end. Now this I can factor. So that's what I'm going to do. Same process. First term goes in the first box. Last term goes in the last box. We need the products, or the factors of negative 24a squared that add up to negative 5a. And those would be negative 8a and 3a. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. So negative 8a and 3a. Our greatest common factor in this column would be 3. Greatest common factor in this row has to be 8. Now I need 8 to become negative 8a, so I have to multiply it by negative a. 8 times negative a is negative 8a. 3 times a is 3a. So my factors are, and I'm going to rewrite this, 3 minus a times 8 plus a. And of course, according to the zero product property, either 3 minus a equals 0 or a plus a equals 0. If 3 minus a equals 0, then a equals 3. I'm going to skip the solving of that. If you're not sure how it works, give it a shot. If 8 plus a equals 0, then a equals negative 8. Again, I'm not going through the steps. If you're not sure how that works, give it a shot. Try and solve the equation, and you'll be able to work it out. So this quadratic equation crosses the x-axis at 3 and negative 8. All right. I want you to complete the last problems on the note guide and bring them to class.